Good evening students, good evening everyone. So welcome to Akshar IIT Foundation. This is Srinivas, your maths sir. Now coming to today's topic, I think it has been so many days to meet you. So how you all? Fine? Yeah, very good. Right. So coming to the today's topic, let us discuss about the problems which we left in our previous class. Okay, yeah, so yeah, see here, we already discussed this exercise, some of the problems, but at last we have left some problems. Let us check that. Yeah, up to the 20th problem, the number of ways that 576 can be expressed as the product of two distinct factors. Am I right? So while you're observing that, the number of ways that 576 can be expressed as product of two distinct factors. So this problem we already discussed that by using the formula. I gave two different type of formulas for two factors and two distinct factors. Am I right? So number of divisors plus 1 divided by 2 or number of divisors minus 1 divided by 2. We already discussed about this. Am I right? Yeah. So before going to the next question, let us once revise the previous concepts. So simply, number of divisors you learn how to find the total number of divisors of a composite number and sum of divisors and product of divisors also. Am I right, children? Good. Yeah. Can anyone say that how we are using that number of divisor formula and sum of divisors, product of divisors? Just quickly say that answers. Yeah. For example, if a number can be expressed as P1 power N1 into P2 power N2 into P3 power N3 and so on like that. That means according to the fundamental theorem in arithmetic, we are learning that every composite number can be expressed as product of primes. Every composite number can be expressed as product of primes. That is known as fundamental theorem in arithmetic. Am I right? Yeah, very good. Now, if n is a composite number, this can be expressed as P1 power N1, P2 power N2, P3 power N3 and so on like that. P1, P2, P3 are here considering as a prime numbers. It can have more than two primes also. That means a composite number can be expressed as product of primes and that prime factorization is unique. Okay? And that the prime factorization is unique. So if you are able to write a composite number in this way, by doing the prime factorization method. Which method? Very good. Prime factorization method. For example, 24 is a composite number. This can be expressed as product of its primes. So what is the first prime number, children? Very good. Your first prime number is 2 and that is only the one and only even prime number. One and only even prime number is 2. Remaining all prime numbers are odd numbers. Right. I am taking 2. Yeah, 2 table 12 times. 2 table. Yeah. 2 6s are, 2 3s are and 3 1s are. So simply the composite number 24 can be expressed as 2 into 2 into 2 into 3. Okay, 2 into 2 into 3 is nothing but 2 cube. Only 1 3 is presenting here, nothing but 3 power 1. So while you are observing this prime factorization, have you got my point? I am just taking the prime factors for 24. That means the 24 I am expressing in the way of product of primes. See here, how many prime numbers, different prime numbers are presenting here? two prime numbers. First one is 2 and second one is 3. See here, P1 and P2. We know P1 and P2. This is having the capacity of only 2 prime factors. Okay, now? Now, the 24 can be expressed as, just compare this one with the general form. N is a number, nothing but a composite number. It can be expressed as P1, P2, P3, that means their powers, respective powers. Got my point? Yeah. So, the 24 can be expressed as 2 cube and 3 power 1. Now, we are going to apply one by one formulas. What is that? First one, number of divisors. Divisors or factors, both are same. Divisors or factors, both are same. We discussed already, right? Yeah. This number is expressed as 2 cube into 3 power 1. Coming to the general form, I am writing the exponents are in the form of n1, n2, n3 like that. So, number of divisors, we can write formula n1 plus 1, n2 plus 1 and so on like that. Am I right? This is one of the important formula for number of divisors. Next one, sum of divisors and product of divisors. We are just substituting the values here. You want me to do this? Yeah, okay. Let us finish it quickly. Number of divisors here. Number of divisors for 24 is, what is the exponent of first prime number? 3. So we have to take, in the place of n1, we are applying 3. n1 plus 1 means 3 plus 1. Such a way, second prime number 3. 3 exponent is 1, 1 plus 1. Nothing but 3 plus 1 is 4 and 1 plus 1 is 2, 4 2 is 8. So total number of divisors or total number of factors for 24 is 8. Okay. We are applying like this. Same way, sum of divisors also. What is the formula you learn until then? P1 power n1 plus 1 minus 1 by P1 minus 1 into P2 power n2 plus 1 minus 1 by P2 minus 1 and so on like that. That is depending on the number of prime factors. Okay? Acha. A simple question to you all. For example, one number is given. That number is in the form of only 2 powers. Like 2 power k. K can be any constants. It can be 3, 4, 5, whatever it may be. In this type of form, that means when a composite number expressed as product of prime numbers, it is having only 2 powers. There is no other prime number, or there is no other prime factor presenting here. That for that type of numbers, what is the number of odd primes? Because here 2 is even prime, right? We discussed that 2 is only the number which is even prime, remaining all odd primes only. Got it? Yeah. According to, if a number, a composite number is expressing as 2 power k, that means k might be 1, 2, 3, whatever. In this form, how many number of odd primes are there? In this situation, how many number of odd factors? Okay, how many number of odd factors, not odd primes? That is only 1. Because 1 is the factor for every number. 1 is the factor for every number. Okay, coming to the even factors, we can take this power k plus 1. Because even prime is 2, 2 power k is there now, so k plus 1. Got it? Very good. Right. So, same way we are learning this formula. At the same time, product of divisors. Product of divisors formula, what is that? Come on. What is the formula for product of divisors of a composite number? Very good. So nothing but it is a formula for the number power number of divisors by 2. Okay. So by using these contents, we are finding the number of factors or number of divisors of a composite number, sum of divisors, product of divisors. This is the concept. I am not explaining this 20th question because we already completed in our previous class. Okay, very good. Now coming to the next question, 21st, very important. See here, the sum of 3 prime numbers is 100. Sum of 3 prime numbers is 100 and one of them, that means among 3 prime numbers, one of them means one of the prime number exceeds another by 36. One of the prime number is exceeds another by 36. Then the one of the prime number is, that means there are 3 prime numbers now. We got a clue here. That is the relation between only 2 prime numbers. Third prime number also we should find, and among them one of the prime number is here. 7 is a prime number, 29 prime number, 41, 67, all are prime numbers. We are going to the options. We have no chance of go through the options because all are prime numbers only. Have to do the process. Okay, now I am taking let one of the number. I don't know the prime numbers exactly. So one of the prime. Usual general method we are taking as x, right? For every unknown things, for finding the unknown values, we used to take x as a variable for finding that value. So I am taking one of the prime number is x. Now coming to the question, children, second sentence. If one of them exceeds, what is the meaning of exceeds? Exceeds, more, all are same. Increased, exceeds, more, increase, all are indicates plus symbol only. That means one of them is x, then another one is x plus 36. Okay. So second prime number according to our assumption is x plus 36. Okay, now from the second sentence, one of them exceeds another by 36. We don't know third prime y. Now according to the problem, first prime number, second prime number, third prime number, when you add it, it will come answer as 100. That means the answer is even number. That is, you have to remember that. Answer is even number. Now coming to the basic concept, basic level. Even number plus even number. What is the answer, children? Sum of 2 even numbers is? Very good. Even number only. Sum of 2 odd numbers? Sum of 2 odd numbers, that is also even. Sum of 2 odd number also even. One even, one odd. One even number, one odd number gives odd number. Okay, na? Did you get my point? So that means if you consider these 3 are odd primes, consider these 3 are odd primes. First one odd number, second one also odd number. When you add both of them, it will give even. Okay. Now coming to the third one as odd number. Third one also odd number. Now even plus odd gives odd number, but the answer is even number 100. Here only we have to identify that one of them is, one of the 3 prime numbers is even. So how many even prime numbers we have? Only one even prime number, that is, what is that? 2. Very good. 2 is the one even prime number. Now I cannot take x as 2. I cannot take x as 2 because x plus 36 must be a prime number. X plus 36 means 2 plus 36 will be 38. 38 is not a prime number. So I cannot take x value as 2. So I have only the option to take y value is 2. Okay na? Now coming here, x plus x 2x, 2x plus 36, y value considering as 2 is equals to 100. Now 36 plus 2, 38, transpose that side, 100 minus 38. How much? 62. So 2x value is 62, x value is 31. We got it. So the prime number is 31 and second prime number is x plus 36. That means 31 plus 36 is 67 and third prime number is 2. So what is our answer, children? See the options? Very good. 67 is our answer. Got it right? I hope you all understand about this problem. Once check. You're just choosing that basic concept also. Shall I go to the next? Just 5 lines, right? Okay, next. Now, sum of factors of 270. Sum of factors also, we are learning a formula p1 power n1 plus 1 minus 1 by p1 minus 1 like that. Let us write. So for finding the sum of factors, product of factors, whatever, we need to do the prime factorization is general process. So let us find the prime factors. Okay, na? Right. I am taking 5 table. 5 5 is 25. Yeah, 2 remains. 5 4 is 20. Now 2 table 27. 3 9s 27. 3 3s 3 1s. So 270 can be expressed as. Just tell me that 270 is a composite number. It can be expressed as product of primes. Oh yeah. Tell me the prime number here. Very good. 2 power 1 into second prime number 3. 3 how many times? 3 times. So we can write as 3 cube. And what is the prime number remains? 5. 5 power 1. Okay na? Now sum of factors. Sum of factors. I am not writing the formula this time. Directly I am applying. First prime number is 2. Yeah, what is the formula? 2 power? Very good. Yes, 2 power 1 plus 1 minus 1 divided by 2 minus 1. Second prime number 3. 3 power? Exponent also? 3. Very good. So 3 plus 1 minus 1 by 3 minus 1. And the third, 5 power 1 also there, 1 plus 1 minus 1 by 5 minus 1. Simplify 1 plus 1, 2, 2 power 2, 4, 4 minus 1, 3, 3 by 2 minus 1, 1. So first bracket value is 3 by 1. Just I am doing the simplification in our mind. Now 3 power 4. What is the value of 3 power 4? 3 into 3 into 3 into 3 like that. It is not 3 into 4. Okay, you should not multiply 3 and 4. 3 power 4 means 3 has to multiply 4 times. 3 3 is 9, 9 3 is 27, 27 3 is 81. 81 minus 1 is 80. By 3 minus 1 is 2. Okay. Now last. 5 power 1 plus 1, 2. 5 square 25. 25 minus 1, 24 by 4. Yeah, after the calculations or simplifications, 4 table 6 times. 4 6 are 24. 2 table 40 times. Now 3 into 40, 120. 120 into 6, nothing but 720. So sum of all its factors is 720. Okay. So in this process, if you take any composite number more than 500 or 600, whatever, it can taken or it can be written or it can be expressed in a form of product of primes. So that's why I explained that every composite number can be expressed as product of, very good, product of primes. Okay, na? Next, 23rd. So this answer is 720. Now coming to 23rd question. Unit digit in the product of first 50 odd natural numbers. There are no need to multiply 50 odd numbers continuously like that. Just if you are observing that 2, 3 odd numbers if you are taking, you will get one idea. That means they are all following one pattern. Can anyone say that? Come on. Very good. Yes. Nearer 5 you will have the answer. See, for example, first 50 odd natural numbers. What is the first odd natural number? Very good, 1. Second odd natural number is 3. Next 5. Okay, no? Now coming to here, 1 3s are 3, 3 5s are 15. When it's come to the 5 table, when it is multiply with 5, while you are observing the 5 table, see 5 1s, 5 2s, 5 3s. When it is multiplied with every odd number, the product will be ending with unit digit is 5. When the 5 is multiplying with even number like 2, 4, 6, it is ending with 0. You can observe the table, 5 table. When 5 is multiplied with every odd number, gives its unit digit is 5. When 5 is multiplied with every even number, gives its unit digit as 0. So here only odd numbers we are taking. So we are multiplying with 5. Obviously it will give 5 is the unit digit. That's it. Very easy, right? Just basic general thinking. No need to multiply, no need to use the formulas and all. Just general checking. So 5 table if you are taking that, while 5 is multiplied with even numbers gives the unit digit 0. When it is multiplied with odd numbers, it will give the unit digit is what? 5. Very good. Okay. Next. I am going to the next question. Number of ways of expressing 180 as product of 2 factors. We are not mentioning about product of 2 distinct factors. Distinct means different factors. It should not be repeated. Okay. Coming to this 180, same way. It is also expressing as, come on. Very good children. Product of primes. Shall we? I am doing quickly. Just check. 2 table, yes, 90. Again 2 table 45, 5 table 9 times, 5 9s are 45. You know prime factorization, no? So that's why I am not going to explain each and every step. So 180 can be expressed as 2 square into 3 square into 5 power 1. Let us find out the number of divisors or divisors of a number equals to, take their exponents. First one exponent is 2. 2 plus 1, and second one also 2 plus 1, and third one is 1 plus 1. Just check their exponents. 2 power 2, so 2 plus 1. 3 power also 2 only. Here also 2 plus 1. 5 power only 1. So 1 plus 1. So multiply 3 3 is 9, 9 2s are 18. So number of factors are 18. Am I right? This one 3, 2 plus 1 3, 2 plus 1 3, 3 into 3 9, 9 2s 18. Now number of ways expressing this 180 as product of two different product of factors is number of factors plus 1 by 2. Okay, na? Or when it is number of factors is even number, you can directly take 18. 18 by 2 is equal to 9. 9 different ways it will have. Okay, now that's it. So our answer is 9. 9 ways. Clear? Next one. 25th. Most important. So the number of positive integers, n for which 3n minus 4, 4n minus 5 and 5n minus 3 are prime numbers. These are all prime numbers. Which prime? We have how many prime numbers? How many? Infinite set of prime numbers. So many prime numbers. We don't know which prime number we have to take. But number of positive integers, how many ways we can take? N value, how many different ways we can take that these three numbers, 3n minus 4, 4n minus 5, 5n minus 3 should be prime numbers. That integer you should take. Let us see that. Now I am writing the given numbers 3n minus 4. It could be prime number at the value of n. Which value? We don't know. N value can be any positive integer. It can be 1, 2, 3, 4, 5, 6, whatever it may be. So many are there positive integers. Infinite number of positive integers are there. Am I right? Yeah, first one 3n minus 4. I am just adding and checking. 4n minus 5 plus third one 5n minus 3. Add all of them. I am just adding the variables first because we cannot add one variable and constant. We should add n terms and numbers separately. Okay, yeah. So 3n, 4n, 7n, 7n plus 5n, 12n. Okay. Now numbers minus 4, minus 5, minus 3. All are negative numbers. We can add with negative symbol. 12. 4, 5, 9, 9, 3, 12. Now both are having 12 as a common factor and minus 1. Now here we got the clue. What is that? This number is expressed as 12 into something. 12 into n minus 1. We don't know n value. It can be 100, 200, 300, whatever it may be. We have to written in the form of 12 into n minus 1. That means 12 is even number. The product also will be even number. That means we are multiplying any number with even. It will be even number only. Now let us take one by one. That means any one of them can be even, no? First one, second one, third one. Any one of them even, then the product will be even number. Now we know one of the even prime number is 2. I am just taking 3n minus 1. The complete term 3n minus 4. This expression completely taken as prime number. I am not taking n value because n is integer. We don't know which integer it will be. I am just taking 3n minus 4 as an even number. Now let us check. Minus 4 transpose that side. Plus 4. 2 plus 4, 6. So n value is 2. We have one chance. N value 2 is satisfying. Let us substitute these values in the remaining. That means in 4n minus 5. 4 2s 8. 8 minus 5, 3. Yes. This value gives 3. Just substitution. Here also 5n minus 3. What is the third one? 5n minus 3. Here also substitute. 5 2s 10, 10 minus 3, 7. Yes, we got a way that is 2, 3, 7. All are prime numbers only. One chance we have. While we are taking 3n minus 4. Let us take second one. This time I am checking 4n minus 5 is 2 or not. Minus 5 transpose that side plus 5. So 2 plus 5 7. N value 7 by 4. 7 by 4 is not an integer. It is not work out. We are not taking it. Now third option is what? I am writing here 5n minus 2. Sorry, 5n minus 3 value is 2. Minus 3 transpose that side plus 3. 5n value is 5. N value is 1. N value having a 1. Let us substitute here. 3 ones are 3. 3 minus 4. 3 minus 4 is minus 1. But these are all must be prime numbers, no? So it is also not work out. We have only one way, that when you take 3n minus 4 is positive 2. Nothing but even prime number. So number of positive integers are, most numbers is 1. This answer is 1. Okay now? Please note it. Is it okay? So first I am doing like this, then taking first one as 2, substituting in second and third one, we got the prime number, set of prime numbers 2, 3, 7. And remaining, second one and third one, not possible. Okay? Yeah. Right. So, until then we have discussed about a number which is in the form of composite can be expressed as product of primes. Am I right? Very good. Product of prime numbers. And we will learn how to find the number of divisors, sum of divisors, product of divisors, and last, number of ways a composite number can be expressed as product of two different numbers. Product of two different numbers. Okay? Yeah, 24th problem, when you add 18 plus 1, we will get 19, but which one? 24. Yeah. Once listen children, right. Nice question. So number of ways while we are expressing is, we got total number of factors is, yes, just we got number of divisors is 18. No. When it is getting even number, 18 is even number, we should consider that number of divisors plus 1 by 2 formula. We are taking only number of divisors is even number only. We are not considering plus 1. Okay. When is getting odd number of divisors only, we are using that number of divisors plus 1 by 2 or number of divisors minus 1 by 2. When is getting even number of divisors, we can directly divide it by 2. So there are 9 different ways. Okay, right. Yeah, thank you one and all.